In this lesson, we're going to take a look at derivative rules. Before we get to these rules, I want to introduce three new derivatives to you. These are all going to be common derivatives and they relate to things we've done previously in the year. If I have the function natural log of x, if I take that function's derivative, it's going to be 1 over x. If I take the trig function sine, its derivative is going to be cosine. And the last one I'm going to introduce today is the derivative of cosine, which is going to be negative sine. We're going to be applying all three of these new derivatives in addition to the polynomial derivative shortcut that we learned in the previous video. We're going to start off by looking at the first rule, which is the product rule. The reason why it's called the product rule is because we are taking two separate functions and multiplying them together to get another function to get the derivative of that new function. Okay. So we can take the derivative of each part individually, but when we multiply two functions together, we have a certain rule to help find its derivative. So for instance, in number 1, we're asked to find the derivative of f of x, which is the product of the function 4x minus 2 and the function sine of x. We can apply this rule. So let's just first talk about what this rule is saying we're going to do. We have a product of two functions which we're taking the derivative of. That's what the outside parentheses are for. To do that, we're going to take the derivative of the first one, multiply it by the derivative times the second function, plus the first times the derivative of the second. So let me say that again. The derivative of the first times the second, plus the first times the derivative of the second. So let's find the derivative of f in number 1. The derivative of the first, 4x minus 2, that's the polynomial function, so its derivative is going to be 4. Times the second, which is sine of x. Now we're going to add it to the first function, which is the 4x minus 2, times the derivative of the second, which we just learned. Derivative of sine is cosine, so it's going to be times cosine of x. There we have the application of the product rule. And typically what we want to do is we want to simplify it so that we don't have these parentheses in front of this function right here. So I'm going to distribute the 4x to the cosine, negative 2 to the cosine, and then that will be it for this problem. So 4 sine x plus 4x cosine x minus 2 cosine x. And there we have our derivative of function f. Now we could take the derivative of this one right here to get a second derivative by looking at each piece individually. We have 3 sets of products. But we're not going to do that in this particular lesson. Let's look at number 2. Let's find the derivative of g of x, which is the natural log of x multiplied by the cosine of x. So let's look back at the rule. Derivative of the first times the second plus the first times the derivative of the second. So the derivative of g is going to be 1 over x, because the derivative of natural log is 1 over x, times the second, which is cosine of x, plus the first, which is natural log of x, times the derivative of cosine, which is negative sine. Let's clean this up a little bit. So this can be rewritten as cosine x divided by x, and this becomes minus natural log of x sine of x. And there we have the derivative of function g. Now let's look at the next rule. Next rule is the quotient rule. So if we have the quotient of two functions, they could be polynomials, they could be natural log, could be sine and cosine, then we can apply this particular rule. So what this rule is saying is, since we have f is the numerator or the top of the fraction, g is the denominator or the bottom of the fraction, this is telling me that the derivative of their quotient is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So in number 3, we have a rational expression when we have the top as a polynomial and the bottom as a polynomial. So to find its derivative, we're going to apply the quotient rule. The bottom, which is x plus 2, times the derivative of the top, which is at 3x squared minus 4x plus 12. So let's distribute that exponent to the front, so it becomes 6x minus 4. So that's this first piece right here, minus the top, which is 3x squared minus 4x plus 12, times the derivative of the bottom. The derivative of x plus 2 is just 1, all over x plus 2 squared. Just like the last couple, let's clean this up. This is the substitution into the quotient rule formula. We just got to do some algebraic work on the numerator to clean it up a little bit. So let's distribute this x plus 2 to the 6x minus 4. So 6x squared minus 4x plus 12x minus 8. The second part I can think about as a negative 1 being distributed to this polynomial. So that becomes a minus 3x squared plus 4x minus 12 all over x plus 2 squared. I see some like terms we can combine. 6x squared minus 3x squared is going to be 3x squared. The minus 4x and the positive 4x cancel, leaving just that 12x. And the minus 8 minus 12 is minus 20 all over x plus 2 squared. And there we have it. You can leave it in that form, or you could multiply out that denominator if you really wish, but you don't have to. Okay, so if you want to have x squared plus 4x in the bottom, that's perfectly fine. Another thing you might want to take a look at and see if this numerator can factor, because sometimes it will cancel with something in the bottom, and we're not going to worry about that in this particular lesson. So we have the product, now we have the quotient rule, and let's look at the third rule. Third rule being the chain rule. Chain rule, each function is kind of linked to each other. They're nested within each other. You think of a chain kind of hooking on to another chain. Okay, so this is going to be used whenever you have a function within another function. Typical functions that are within others are going to be trig functions and natural log. Even polynomials as well. Okay, you can have polynomials in place of their x's. This is the derivative of the composition of two functions. This looks like a little confusing right here, but this is really just the composition of two functions. And here's what this rule is saying that we're going to do. We're going to take the derivative of the big function, the most outward function, still evaluated at whatever's inside. And then we're going to multiply what we get by the derivative of whatever's inside. So again, take the derivative of the big picture function and keep whatever's inside evaluated at that function, multiplied by the derivative of whatever's inside. So let's look at number 4. I want to find the derivative of number 4. Let's look at this. We have cosine of x cubed plus 2x. This x cubed plus 2x is within the cosine. So the cosine is going to be my f of x, and my g of x is going to be x cubed plus 2x. So we got to look at the big picture first, which is cosine. Derivative of cosine is negative sine. So it's going to be negative sine, but keeping everything inside exactly as it is, so still evaluated at x cubed plus 2x, times the derivative of the inside. So the derivative of that polynomial x cubed plus 2x is 3x squared plus 2. All right, let's clean this one up a little bit. And as we do so, let's be careful. This x cubed plus 2x is grouped with the sign. They're not going to be separated at all. So I'm not going to distribute this 3x squared plus 2x into this x cubed plus 2x. I'm going to instead distribute the 3x squared to that negative sign and the 2 to the negative sign. Okay, I'm not going to be multiplying these two sets of parentheses. It's not sine times something times something. It's sine of this one quantity times the 3x squared plus 2. So let's see what that looks like. So distribute the 3x squared. Becomes negative 3x squared sine of x cubed plus 2x is the first distribution. Now the second one, 2 gets distributed to the negative sign, so minus 2 sine x cubed plus 2x. All right, and then we have it. There's our answer for the first derivative. And notice if I want to take the second derivative, I can use the product rule coupled with the chain rule, so it gets a little more complicated. And we have the product rule, and then we have just a chain rule here with the product rule with the times the 2. Okay. So We could take the second derivative, but that's going to take a little more work. So we have to do a derivative within a derivative. Let's look at number 5. Find the derivative of g of x, which is natural log of sine x. Natural log of sine x, we have the big function is going to be the natural log. So we're going to first take the derivative of natural log. So if you look back on the front page in the notes, the derivative of natural log is 1 over x. So I'm going to take it to become 1 over sine of x, because natural log of the big picture, this is what's inside the natural log. That is like your x in the formula, so it becomes 1 over sine x. Then I multiply by the derivative of whatever's inside. The derivative of sine is cosine. And you can probably see that this one can actually simplify even further, because we can make this a cosine x over sine x. And if you remember your time from the glory days with the trig unit, cosine over sine is cotangent. So the derivative of this function is going to be cotangent of x. Interesting little thing. You never think that cotangent and natural logs might be related to each other, but they actually are in some kind of way. Calculus, you're going to see a lot of interesting relationships. All right, let's look at some applications now. So we saw all 3 rules. We saw the product, the quotient, and the chain rule. What we're going to do now is apply what we did in previous lessons by finding the slopes of some tangent lines using these 3 rules. So let's find the slope of the tangent line to the function h of x is equal to the sine squared of x. Now we can actually think about this as 2 different functions. And I'm going to kind of show you both, just so you kind of see that they're actually the same thing. I can represent h of x as sine of x times sine of x as a product of 2 functions. I can also see it in a different way, as a chain rule. If I think about it as sine of x squared, then I can think of the sine of x as within an x squared. It's within a polynomial function. So actually, let's see what happens when we use both of these different rules. We should get the same thing. So let's use the product rule first. Product rule, remember from the front, says the derivative of the first times the second plus the first times the derivative of the second. So that means we have h prime of x, derivative of the sine x is cosine x, times the second, which is sine x, plus the first times the derivative of the second. Well, these are both sine x, cosine x, so we can combine them as like terms. 2 sine x, cosine x, and then we have the derivative of h of x. Let's just see what happens when we take the chain rule. The chain rule says we have to take the picture of the big thing, which is going to be the x squared, and then take the derivative of what's inside and multiply it together. So the derivative of x squared is going to be 2x, so it's going to be 2 sine x, times the derivative of sine x, which is cosine x. And they both give you the exact same thing. So some problems you're going to see as one or the other rule, and that's fine. Sometimes you're going to see it specifically as one rule to apply. Either way, you should get the same thing. All right, so there's the derivative of sine squared of x. Let's find the slope of the tangent line at that point of x being pi over 3, which pi over 3 is the same thing as 60 degrees. Remember back from our trig days. So we want to find out what is the derivative of h at pi over 3, which I'm going to write pi over 3. So it's going to be 2 sine pi over 3 times cosine pi over 3. So it's really the same thing as 2 sine 60 degrees, cosine 60 degrees. So we might want to think back to our special right triangles to help solve this problem. These are both in the first quadrant, so we just deal with the straight up special right triangle. Let's use the one with the hypotenuse of a 2. Across from the 30 is a 1. Across from the 60 is root 3. So sine of 60 degrees is opposite over hypotenuse, so root 3 over 2. And then cosine of 60 is adjacent over hypotenuse, 1 over 2. That simplifies. These 2 cancels, leaving just root 3 over 2. So the slope of your tangent line is root 3 over 2 at the x value of pi over 3. All right. Number 7, find the slope of the tangent line at to this function right here, which is a rational function, at x equals 2. So now we actually have a rule to find the derivative of a quotient, or of a rational expression. We have a quotient of two polynomials. So we're going to look back at the front side of our sheet to see the quotient rule. It says the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. If I want to find the derivative of f of x, it's going to be the bottom, which is 2x plus 5, times the derivative of the top, which is just 3, minus the top, which is 3x minus 3, times the derivative of the bottom, which is a 2, all over 2x plus 5 squared. And like always, let's simplify this up. Let's distribute that 3 through to get a 6x plus 15. On this side, I'm going to distribute the negative 2 through, so it becomes a negative 6x plus 6, all over 2x plus 5. And I'm going to be evaluating, so I'm going to keep this as a 2x plus 5. It makes my life a lot easier, instead of having to multiply it out and get 3 terms there. All right, let's simplify this further. The 6x's cancel, leaving just the 21 on the top. So the derivative of f is going to be 21 over 2x plus 5 squared. So if I want to find the slope of the tangent line at this point right here, then I'm going to be evaluating the function of the derivative at 2, which is 21 over 2 times 2 plus 5 squared. 2 times 2 is 4, plus 5 is 9, so it becomes 21 over 9 squared, 21 over 81, and you can clearly see from this step right here that they have 3 in common. So if I divide everything by 3, I get 7 over 27. So the slope of the tangent line is 7/27. Now we could actually take this a step further. It didn't say 2 in the notes, but I could say what's the equation of the tangent line at x equals 2. In that case, we just have to find out what f of 2 is going to be. 3 times 2 minus 3 over 2 times 2 plus 5. This gives us 6 minus 3, which is 3. This gives us 4 plus 5 is 9. So f of 2 is going to be 1/3. So I can actually find the equation of the tangent line because it has the point 2 comma 1/3 with a slope of 7/27. So I can have the equation y minus 1/3 is equal to 7/27 x minus 2. Okay, so if I ask you to find the equation of the tangent line, we can actually do that here just like we did in the previous video. We just now have the new rules to apply. So that is the last lesson with the derivatives. I look forward to seeing you in the next part of the calculus world, which is the integration part.